So now we begin.
Apparently.
Yeah, okay. Well, I see that both of us attended Royal School of Mines at Imperial College, which is a bit of a coincidence. Even though we haven't met, we have a history in common, because at some point after that, you ended up at Scripps Institution of Oceanography, and I ended up at Woods Hole Institution of Oceanography, so we probably know a lot of the same people.
I'm sure we do.
And we both had careers in industry, because you had one in the mining industry and I had one in the petroleum industry, and now here we are in academia.
Yes.
So maybe we could start by you telling me how you got into the climate science side of things.
Sure. Well, so I started life as a geologist, but I always had a lot of interests. Found it actually hard to decide what to study in university because I had too many different interests. So in graduate school, I discovered history of science as a field, and that seemed a wonderful field because it opened up the possibility of studying science, but in a broader and more capacious way than if I were just doing scientific research alone. And so I transmuted or transmogrified into a historian of earth science and worked on a number of different issues, initially mostly on the history of plate tectonics, and then out of the plate tectonics work, I became interested in oceanography because so much of the key evidence for plate tectonic theory came out of oceanographic research. Right. And in the process of working on oceanography, I became familiar with the work of scientists like Roger Revelle, Dave Keeling, Bert Bolin, who had started to speak about the risk of man-made climate change in the 1950s. And I thought that was pretty interesting, since I don't think most people knew at that time that there was this older history. Later I learned it went back even further. And so I started pursuing it, and one thing led to another, and now here I am.
Right. Yeah, well, I started from the science side rather than from the history side. I was always interested in the fact that the sediments have a record of the climate change within them. You know, I think everybody knows coral reefs are found in the tropics, and similarly boulder clay is found in polar regions. So we knew in geology that the climate is imposed on the sediments and they contain a record. So if you go back through time and you drill down into the sedimentary record, what you have is like a tape recording of climate change through time, and I found that was really kind of fascinating. And then with time we got access to the deep oceans through the deep sea drilling project, which started in 1968. So we've got these wonderful long drill cores of undisturbed sediment from the deep ocean, and that gave us this fabulous climate record. And then in the 1980s, we got these great ice cores drilled through the Greenland and Antarctic ice caps, and they gave us a climate record going back 400,000 years. And then in the 2000s, the European project on drilling in Antarctica gave us this record that goes back 800,000 years. And the neat thing about that is that the ice contains bubbles of fossil air. I mean, who imagined we would ever have fossil air? It's just mind-boggling. And that fossil air has carbon dioxide in it, so we have a record of carbon dioxide going back through time. So we can start to tie the geological record of climate change, things like corals and boulder clay, we can now tie that to the atmosphere in a way that we just couldn't do before. And that's been very helpful to understand how the world has changed. And what we know from looking at the ice cores is that in the past, we're living in an interglacial now, a warm period, but in the interglacials of the past, the temperatures were 2 to 3 degrees warmer than today, and the sea level was 4 to 9 meters higher. So it seemed to me there's a message in the rocks and in the ice about our potential future, there doesn't seem to me to be any strong reason why, if we push temperature up again to those same levels, we should expect sea level to go up correspondingly. And I think that's a fascinating aspect of the whole debate on climate science. It takes you away from numerical climate models to the real geological record with real data, not numerical models, to tell you what might happen.
So it's so great talking to you, because everything you say makes me think of 5 more things we could talk about. So let me ask you just one thing about that then. So early in my work, my research, I wrote a rather now well-known paper about model verification in earth science, basically saying that, we have to have a sort of healthy skepticism about models, because models are pictures of the world, but they're not the world. And now I've been recently accused of being a hypocrite because, well, why do I believe climate models if I was, were critical? I was critical of models earlier. And the answer to that, of course, is, well, it's not a matter of believing the models. Models are one of the lines of evidence we have with respect to climate change, but by no means the other evidence. And I often cite the ice core data, for geologists who want to have empirical observations. I often say, well, look, it's not just about models. We have all this data from sediments. We have all this data from ice cores. But when you said we know from geology that in the last interglacial, I think you said it was 2 to 3 degrees warmer, and sea level was 4 to 9 meters high. Is that right? So how do you reconcile that with the current model predictions that are predicting, half a meter of sea level rise to go with a 3-degree climate sensitivity? That seems much, much less. Do you think the modelers are underestimating what the sea level rise will be?
No, I think there's the answer to that is that you have to look at the Earth as an equilibrium system, and the temperature goes up, the carbon dioxide goes up, that makes the temperature go up some more. But it takes much longer for the sea to respond. So right now what we're seeing is that the sea is warming, and as soon as you warm water, it expands. Similarly, with the warming of ice, the ice melts on land and goes into the ocean, so that adds some more. But it takes a very long time for all the ice to melt so that the sea level will respond fully to the temperature change that's happened. It also takes a long time for the heat that we're putting into the surface ocean to get down into the deep ocean so that the whole water column is heated. And so you can imagine a time delay of maybe 200 years from the start of putting temperature up to the point where sea level is fully responded. So the carbon dioxide and the temperature work in sync, but the sea level is a lagged effect.
So that's what I thought you'd say, and I think that, to me, that shows why the geological perspective is so important, because I think most people don't get that, and they see the IPCC result and they say, well, a third of a meter, half a meter by 2100, that doesn't seem so bad. What are you getting so stressed about? I mean, in reality, half a meter of sea level rise is actually still quite a bit.
Yes.
But I think you're also pointing out another really important point is the disequilibrium aspects of these systems and the reality that as the world equilibrates at these warmer levels, the consequences will play out over a long period of time. And of course, if we continue to add more greenhouse gases, then we're not equilibrating at that level, but we're going to remain in a disequilibrium situation where things continue to get worse.
Yeah. Let me give you an example of what's happening at the moment in West Antarctica. The major glaciers draining the inland ice basin are speeding up. And the reason they're speeding up is not because they're being warmed from the surface. It's because this warmed upper ocean water is getting in underneath the ice shelves. It's melting them from below. And what that does is it removes the buttress that's keeping the land ice from pouring faster into the sea. And so the glaciers of West Antarctica are now moving faster. They're thinning faster. And I've been told by people working for NASA and others who are studying West Antarctica in particular, that they think they're now in a phase of literally runaway melting. When they say runaway, we might think of it as a runaway horse, but it's an extremely slow runaway horse. It's not going to happen overnight. But it means that part of West Antarctica is seriously under threat of losing a lot of its ice. If it does, that could raise sea level by about 3.5 meters maybe, but not within the next 100-year time frame. So we've always got this discrepancy between what the climate models seem to be saying and what we know is likely to happen to sea level.
Right, and I remember when that NASA paper came out, I was quite shocked by it in a way because it was much more worried tone than what we'd heard from the climate community previously. And even though it's true it won't happen over 50 to 100 years, in the articles they talk about something that could happen, say, over 200 to 300 years. And that's a human timescale. I mean, that gets us into this whole Anthropocene question. Something that happens over 300 years is something that historians will worry about, something that future historians will see as a driving force of social and economic and political change. Right. So now geologic change, climatic change is now happening on a scale that historians and sociologists and economists would need to worry about.
Yeah.
And that's a huge change, don't you think?
Yeah, it is a very big change. I tend to describe what's happening when I'm talking to people who are lay people and not scientists, that you can think of this as a creeping catastrophe. It's not like a tsunami. With a tsunami, bang, you got the tsunami, everybody on the beach gets drowned. This is not like that. If it all happened at once, everybody on the beach would be drowned, but it's not. It's going to have the same, if you didn't do anything about it, it would have the effect of a catastrophe. But it's creeping. It's really very slow. That's why people find climate change so difficult to get to grips with. The actual change in temperature that we have had over the past, the past 100 years has been 0.1 of a degree per decade. Now, who in this auditorium can measure on their garden thermometer 0.1 of a degree per decade? I can't on mine. On my garden thermometer, the temperature goes up daily and falls again by 10 degrees. And the sea level is going up by that much, which is 3.3 millimeters per year. Again, this seems like nothing to, let's say, the man in the street or the woman in the street. So
no, women are a bit smarter.
They get it. Yes. You can multitask, can't you?
Exactly.
Yeah. So my wife keeps telling me.
Right. We can walk and chew gum at the same time. Yeah.
Yeah.
I do know an off-color joke related to that, but I won't tell it here. We'll have to go out for a beer later for that.
Moving on.
Yes, move on. I know you have lots of other things you want us to talk about, and we could spend... But I was going to say one other thing, though, but there's also an interesting thing that relates plate tectonics and climate change, too, which is that Alfred Wegener, who first proposed the theory of continental drift, the original data that made him begin to think about continental drift was paleoclimate data from the geologic record.
Yes.
And he thought that the evidence of glaciation in tropical regions or coral reefs in what are now high latitudes was proof that there had been some kind of very dramatic climate shifts in the past. And so he began thinking about what the explanation for that could be.
Yep.
And that was partly how he initially began thinking about continental drift.
Wegener was a very interesting guy. I mean, he was a German scientist who'd been trained in the natural sciences, and he became a meteorologist. But he also had a profound interest in glaciology. In fact, he died on the ice cap, rather Britain's Captain Scott. And they eventually found his body buried under, layers of snow when they went looking for him. But so he knew about astronomy, he knew about geology, he knew about meteorology and glaciology. But when he presented this idea of continental drift, it was as if he was talking to a geological community that had cloth ears, because he was a can we believe a meteorologist can tell us about geology? Well, of course not.
Yeah, although I have to say, to defend the geologist, because I wrote a whole book about this, I think that aspect of his work was somewhat overplayed. Most people at the time viewed him as a geophysicist, and they did view him as a serious person whose ideas needed to be read and listened to. And many American geologists were reading his work actually quite seriously. But it is true, I think, that the questions of specialization are important because they get worse as time goes on. I mean, Wegener in some ways is the last of a 19th century style of scientists who really had a kind of very broad compass, as you say, of astronomy, meteorology. Actually, he held the world record at one point with his brother for the highest balloon ascent, which was a scientific balloon ascent.
Which was part of meteorology,
Exactly, and wrote a textbook on thermodynamics of the atmosphere. But already at that time, there's a tension between that sort of broad 19th century style, sort of almost Humboldtian approach and the rising specialization of earth scientists in the 20th century.
Yeah, which is partly why he was ignored by a number of geologists, let's say. I bow to your superior.
Yeah, we won't say ignored, but at least rejected.
But what he did do was he got together with a German climatologist, that's Vladimir Köppen.
Right, who was his father-in-law.
Yes, he was. He married his daughter Elsa. And the two of them wrote this very interesting book, The Geology of Past Times or Past Climates. Unfortunately, it was only ever published in German. But I understand from you and Tida that it's now, this year is translated and it's going to be published in English.
Excellent.
Probably late this year.
Excellent.
So I think there's a celebration right now of Wegener's life and times, and that will be one of the products. They're going to reissue the Wegener and Köppen book, and they're going to do it in English as well as in German. So that's really good news.
Yeah, that is good news.
So that whole paleoclimate aspect of plate tectonics, of course, was useful because, but it didn't catch on until the 1960s with plate tectonics as an emergent concept, as you were. I mean, in 1960, as an undergraduate, I was still writing essays entitled "Continental Drift, Yes or No."
Well, at least there was a possible yes there. Right,
because plate tectonics didn't come along really and get consolidated until 1968.
Right.
So it was only in the early 70s that people started producing these plate tectonic reconstruction maps on which we could put past climate information that would help us to understand how those climate-sensitive sediments got to be where they are.
Right. So that can be a segue into our homework assignment, which is to talk about petrogeology and denial. So you mentioned how in the geologic record we see tremendous amounts of evidence of past climate change. And as you know, some of our geological colleagues use that as an excuse to say they don't believe in man-made climate change. They'll say, oh, well, we know the climate's always been changing, so, this is just another natural change. So let's talk about that. How do you respond to colleagues, your own colleagues, who say things like that to you?
I call this the mindless mantra.
But you're not going to meditate on it. There's always been natural climate change. There's always been natural climate change.
You mentioned this when you gave your lecture the other night. Petroleum geologists are very fond of saying, the climate is always changing, as if we don't have to worry about anything. In fact, if you go to the website of the American Association of Petroleum Geologists, they will recommend you to a book published in 2001 by the AAPG, in which the first article is written by a guy called Lee Gerhardt, and it encapsulates that idea that we really don't need to worry because the climate's always been changing. And he said, I have a quote here. It says, the non-equilibrium systems that control natural phenomena on Earth very likely dwarf man's ability to affect climate conditions on a global scale. You said something like that in your lecture the other day, that geologists, particularly the ones associated with industry, are kind of fond of saying not only the climate's always changing, but we humans are too puny to do anything about it. Haven't they heard of the ozone hole?
Yes, well, you would think so. But this is what I talked about in our opening lecture. If you've been trained all your life to think that mankind is too puny to have an impact compared to geological and geophysical forces, and that the time scale of human existence is trivial compared to the vast dark abyss of geological time, and now add to that you actually have a financial and pecuniary interest in defending your employment, and not just financial, but psychic, right? If you work for an oil and gas company, your livelihood, your living is tied up with drilling for oil and gas. So now you have to confront, A, that what you were taught in school might not be right, B, the world is changing in ways that you didn't anticipate, and C, that means that the work you do, your livelihood, may actually be causing really serious damage to people all across the globe. That's a heck of a lot to get your head around. So not that I excuse those people who make up mindless mantras, but you can have a little bit of sympathy. We can appreciate a little bit of the tough spot that those people are in.
I agree. And to me, that means we need to educate our colleagues as well as other scientists in precisely what's happening. And that's one thing that I've been personally trying to do, and also trying to do through the Geological Society of London. One of the former presidents just a couple of years ago asked me to form a group to come up with a statement on climate change. We pulled together a small group of experts, people working on ice cores, deep sea cores, all sorts of stuff, to try and tease out all this new information that was coming out and make it available to our membership, many of whom are from the petroleum industry, so that they could see this new information, that a lot of it had come along since they were undergraduates even.
Right.
The ice core data from the Epica drilling is 2006.
Right, it's just new.
It's new stuff.
Right.
And so we did that, and we published an addendum to that on the Society's webpage for everybody to see in 2013, to come out at the same time as the latest IPCC report. So one of the points that we were trying to make was, yes, the climate has always been changing, but that's not what's important. The important thing is, why was it changing? How was it changing? At what rate? And what was causing it? And if you can understand those things, then you have a much better handle on what causes climate variability. And if you can do that for the geological record, then you have a better handle on why climate is changing today, and even how it might possibly change tomorrow.
Yeah, and I think that's terribly important. I think it's so good that you're doing that work, because I think something a lot of people don't realize is, for a lot of people, science is science, this sort of monolithic thing, And of course, the reality is that it's really sciences. There are all these many different sciences. And I think a lot of people don't realize that outside of their specialty, many scientists know more about some other branch of science than a layperson. And sometimes they even know less because they've never even bothered to find out, because the very fact of specialization can make you actually quite ignorant of other fields. So a lot of geologists, like you mentioned the ozone hole, but a lot of geologists,
it's not their business.
It's not their business,
No.
and they may not actually understand it. They might not have taken atmospheric chemistry when they were being trained, if they were trained as hard rock geologists. I know when I did my undergraduate degree, I don't think we had any meteorology in the program. I think we had a few lectures on the oceans.
Yeah.
Maybe if you took the soft rock track, I think there was a bit more like marine sedimentology or marine geology. But we weren't really, it was really lithospheric oriented. You know, we really weren't taught much about the hydrosphere, the atmosphere. So now as you say, these other things come along. You're not really keeping up. You're in your own specialty. Maybe you're working in an industry where you're not actually encouraged to spend time on things that aren't directly relevant to the job that needs to get done. So you can see how people get into their own little boxes, and they knew there was an ozone hole, but it hasn't really penetrated their consciousness what that really means. What does it really mean?
Yeah, I think that's really true. I think this is the specialization of science that forces us into particular boxes. And I found I got dissatisfied with this statement on climate change that my group wrote for the Geological Society, because we had to condense it in too small a space to be readable by the public on a website. So I've actually written a book about it, which will be published next year, on Earth's climate evolution. And it's fairly technical. Hopefully it will educate undergraduates and postgraduates and maybe some of those people working who would like to know more about what's going on. But I had to learn an awful lot to do that, because I had to cross those compartmental boundaries. I had to find out about solar terrestrial interactions. I had to find out isotope changes, the fact that when the solar wind declines, cosmic rays impact the upper atmosphere.
Beryllium isotopes,
you get
right?
beryllium-10, you get carbon-14, they get into tree rings, they get into ice cores. That tells you how the sunspot cycle has been varying through time.
Right.
You don't need a thermometer necessarily to get these measures. There are other ways of getting these measures. And a lot of that information is also new, and it comes from a community that geologists aren't used to communicating with.
Right, and as you said, it takes a lot of work to plow through all that technical material. So now you have to have the patience, you have to have the technical ability to read the literature, and then you have to figure out a way to explain it in language that ordinary people can understand. And as you just said, you've written a book that's still fairly technical. So now you have to reduce it to a one-page statement. And even though that's a hard thing to do, I think it's terrifically important that we not give up on the one-page statement either, because that's all that most of our colleagues will probably read.
Yeah. The other thing that they tend to read, and I think this is true of people who are in a business where they feel threatened by the information coming from outside, is they'll tend to look for confirmation. And you can get a lot of confirmation about denial of climate change from the web. Not from reputable scientific sources, but from the web. However, I'm sure you probably had this experience too. If you look carefully at what knowledgeable climate contrarians or denialists are now saying, people like Richard Lindzen, professor at MIT, he's an eminent meteorologist. He's on the denial side of the argument. But even he will stand up. I've been to a lecture of his. He stands up and says, yes, carbon dioxide is a greenhouse gas. Yes, we're putting it into the atmosphere. Yes, it is causing warming. It's just that I don't think that the warming is going to be as much as the IPC says it's going to be.
Right.
Okay, so here you've got one of their own experts, if you can say it, from that side, from the dark side, who's saying the same thing that we are, but just saying it's not going to be quite as much as you guys say.
Right, but Richard Lindzen is an exception, because there are many others who deny that there even is warming, or that, and even most recently, I track, I've written a whole book about this denial industry, and it is an industry. The latest one is William Happer, another one of these physicists who now, is recycling an old claim, one that we saw in the early 1990s, CO2 is good for us, it's the food of life, it's not a pollutant. Well, that's an old argument. You know, how a scientist, a physicist who understands radiative transfer can stand up in public and say things like that? Well, I wrote a whole book trying to explain how that's possible. But, you know, we're up against a pretty serious challenge because, you know, there are people like Lindzen who understand the science but just dismiss its social and political and economic significance. So way outside his specialty as a meteorologist, but okay. Or who insist that they're right and the rest of the world is wrong, because that's essentially what Lindzen is doing. People like Happer who just say things that we know are scientifically untrue, but nevertheless they get invited to Congress to say these things in front of senators. You know, people who attack the motivations of scientists, people who attack, you know, the IPCC. There's so many different ways in which the science is challenged that it becomes incredibly difficult for scientists even to keep up with the challenges, much less to know how to handle them and deal with them.
There is another aspect to this climate story, though, which people like Lindzen ignore, and I think they ignore it at their peril, and that is the whole question of what happens when you put carbon dioxide into the atmosphere. You put it in the atmosphere, and immediately it starts exchanging with the ocean. So what happens is you increase the amount of the atmosphere, it increases the amount in the ocean. What that does chemically to the ocean is it makes it very slightly more acid. And we have a very good geological example of what happens when you do this. So we have to go back to 55 million years ago. There was this massive event, a massive injection of carbon into the atmosphere. Now, it was something like over 1,000 gigatons, and a gigaton is 1 billion tons, so that's a lot of tons. And what happened was this massive amount of carbon went into the atmosphere. Immediately, the temperature went up by 5 to 6 degrees, so that was a planetary warming on a very big scale. And what happened was the sea level also went up, but more importantly for the purposes of this discussion now, the ocean went acid, and what we call the carbonate compensation depth at the bottom of the ocean that allows carbonate sediments, the remains of plankton, to rest there, rose in the sea. Its level rose, and all that carbonate dissolved. There's a very interesting public statement about that in the October 2011 issue of National Geographic. It was kind of a nice article.
I'll look at that.
So ocean acidification is a really important side effect of what we're now doing to the planet. And it seems to me that that's largely ignored by those who are focusing solely on the temperature. We're talking about a change to the planetary ecosystem, not just carbon dioxide causing warming in the atmosphere.
Yeah, I agree completely, and I think I wouldn't even call it a side effect. I'd say, actually I think that if the public are trying to get their heads around why this matters, rather than talking about 0.5 meter or a meter of sea level rise, we should really be talking about ocean acidification and the potential it has to destroy the coral reefs of the world, destroy one of the most important ocean ecosystems, and potentially to disrupt phytoplankton, at the base of the marine food chain.
Yeah, well, if you take the Southern Ocean, in the Southern Ocean you have these tiny little creatures called pteropods, which are the size of a pinhead, and their skeletons are made out of calcium carbonate.
Yeah, I remember those from micropaleontology. They like give you eye strain trying to look at them.
They have these wings that come out, and they sort of fly through these little pinhead-sized things, sort of flying along. But their ability to form those skeletons will be compromised by the fact that the ocean becomes very slightly more acid. And they are at the base of the food chain.
Yeah, that's pretty worrisome.
So the big things we eat depend on those.
So do we know how much of a change in ocean pH it would take to compromise the survival of the pteropods?
Well, right now the pH has gone down 0.1 of a unit. That doesn't sound like very much, and that's because the scale is logarithmic. So actually 0.1 of a unit decline is a 30% decline already.
Yeah.
So if it goes down another 0.1 add-on,
60,
cumulative, it's a pretty serious change.
And during that 55 million year ago event, well, actually two questions of that. Do we know what caused the CO2 burst? And the second, do we know how much, or can we guesstimate or calculate how much pH change was associated with that event, with that gigaton of carbon?
I haven't seen anybody do the actual pH calculation, but I assume that it would be easy to do. I would have to find a man who knows, or a woman who knows.
It'd be good to find out, because that gigaton of carbon is roughly the amount of carbon that's sitting in proven reserves of oil, gas, and coal in the world today.
Yeah, the problem with the reserves, that brings up another question about oil companies burning their reserves. You know, oil companies' share price depends not only on the oil in the reservoirs they're currently drilling into and extracting from, it also, they have to have 100% replacement value on the stocks. So they have what they call reserves, which is oil in the ground that they're not yet drilling into, but they know that they can drill into. And if governments change their approach to global warming to make it more difficult for companies to drill for oil, then those assets will be stranded assets. They'll be like these mortgages. They'll be toxic assets. And that'll be a problem for companies. So the whole question of assets is rather important. There is as much oil in these reserves in the ground for, I think, if you burnt it all by 2050, you'd be putting 5 times more carbon into the atmosphere than we could possibly tolerate.
Yeah.
So hopefully they won't burn it.
So let's talk about the oil companies. So you worked for BP and Esso, two of the world's largest producers of oil and gas. So I wanted to ask you about BP, because back in the 90s, BP made this great announcement that they were going to go beyond petroleum. They had advertisements. I remember flying into Heathrow Airport and seeing these big signs and actually being very optimistic and thinking, well, okay, things are a bit of a mess in the United States, but they're looking up over here across the pond. And Lord Browne made this big speech at Stanford. He talked about the responsibility of corporations, not just to their shareholders, but to all of humanity. So what happened to that?
Well, it was 1996, 1997. It wasn't just BP, it was also Shell.
Right.
They both, they previously had belonged to an oil company group called the Climate Coalition.
Global Climate Coalition.
Thank you. Yeah. Global Climate Coalition. And they broke ranks, the two of them, and said, no, we're going to invest in renewables. And that was not just biofuels, but also wind and solar. And that was going to become part of their portfolio. So in a sense, they were saying, we're going to become energy companies, not just oil and gas companies. And they kept that up until very recently, but within the past 2 years, both BP and Shell have pulled the plug on all of their renewables work except for biofuels. So what they're saying now is, biofuels, that's liquid, so we can deal with liquid because we deal with oil and gas. It's something we know about. It's close to our business. But the rest of it's not profitable, not going to do it.
So what happened to that argument about having an obligation to humanity as well as to shareholders?
Yeah, interesting question. Yes. You
We'll leave it at that. All right, we need to have another.
If I had Lord Browne's telephone number, I would give it to you and you could ask him right now.
Well, I'm planning to ask him that question. I don't have his phone number, but I do have his email address. I'm going to follow up on this question.
But I've seen statements from ExxonMobil, to the point where what they're saying is, look, the population is growing. Demand for our products is growing. You've got to have energy to drive your cars, trains, planes. You've got to have energy to have your iPads, your iPods, all of the gadgets that we have today. And not only for what we call Western civilization, but, the growing markets in Asia and what you might call the developing world. So we're going to keep producing this stuff because those people need it.
Of all the things that people say, of all the various forms of denial, none of them make me more angry than that. Because here it is, after saying that they have their obligation to their shareholders, but we're actually humanitarians. We're actually doing this because poor people need it. Yes. I mean, I think, for one thing, it's just hogwash because we know that's not why they're doing it. They're doing it because it's the next frontier of selling oil and gas. But I think also it's so deeply, fundamentally dishonest because, of course, we all know that the poor people of the world will suffer more from climate change than those in the rich world because their adaptive capacity is less, their ability to build appropriate infrastructure is less. So what poor people of the world need is energy, that's true, but they don't need energy from oil and gas. They need energy from clean, renewable sources, and they need distributed energy that they can manage themselves because we've seen across the globe, people talk about the resource curse, right? How countries that have resources, that have their own oil and gas, like Nigeria, for example, it hasn't helped the people of Nigeria live better lives, right? It's caused all kinds of terrible problems, environmental problems, political corruption, and the resources, the money, the wealth that's been generated from Nigerian oil has not gone by and large to benefit the people of Nigeria.
Yeah, well, the question that you're raising there is got nothing much to do with science and everything to do with politics and economics. And on the political side, we have to blame governments for not doing enough to regulate corporate activity. And on the economic side, in a sense, we have to blame the current, what should we call it, market fundamentalist paradigm that is been driving the world since Reagan and Thatcher got into power, basically. Milton Friedman's school from Chicago, Alan Greenspan, you know, these have driven a truck through society and made gaping holes. This is all part of that problem. So there is a paradigm shift is required if we're going to get back to where we can regulate the production of these materials, invest more in their renewable replacements, and get to where we need to be, which is with an atmosphere that's not used as a dumping ground by oil companies who don't pay for its use.
Exactly. I agree completely.
I used to hear something called the polluter pays principle. Do people remember the polluter pays principle?
Yeah, well.
Are these polluters paying?
No, of course they say, oh, but we all use all these products. And that's true, we do.
We do,
but we don't all profit equally from them, and we don't all suffer equally from the consequences.
No. There is another problem which I learned about. I picked this up in the airport. I don't know whether you've seen that. Naomi Klein's thing.
Yeah.
This changes everything. Naomi Klein wrote the Shock Doctrine and No Logo. She picks on really big. She likes to target really big issues, doesn't she?
Yeah.
But one thing I learned about this, which I didn't realize, when the UN Framework Convention on Climate Change was written in 1992 in Rio, at the same time, the same governments were writing the World Trade Organization rules, and they had to write in to the UNFCCC definition. What did she say? Well, basically the agreement had measures taken to combat climate change should not constitute a disguised restriction on international trade. How about that?
Yeah, well, there it is. So there's, in a nutshell, part of the problem, right?
So international trade is designed in such a way that it can do what it likes, regardless of its effect on the environment.
Right, which is a pretty, neat trick they pulled there, right? Because all the rest of us are subject to the rule of law. All the rest of us assume that when we do things in life, we have to obey the laws and the rules, and we have to think about how our actions affect the people around us. And we raise our children to think that. I mean, how often did you say to your children when you were raising them, well, just think about other people for a moment, right? And yet somehow the corporate world, international trade, has been given a pass, a free pass, a kind of carte blanche. Yeah. So I think you're right. Somehow this needs to be rethought, but it's very difficult because now some of these things have been built into the structure of international governance. So that means some really serious rethinking about what are even the mechanisms by which we can think about how to hold people accountable, make the polluter pay, and also create the right incentives, because right now we have a lot of wrong incentives. The World Bank estimates, I don't know if she talks about this, but the World Bank tracks subsidies to fossil fuel production around the globe, $700 billion every year in global subsidies to fossil fuels. Yeah. $700 billion.
And those are the same people that complain about much smaller subsidies.
Exactly, tiny, exactly, tiny, not even a tenth or a hundredth, right. And the same people who would say they're opposed to renewables because they don't want the government subsidizing them, they want the free market to decide. But it's not a free market, it's an incredibly heavily subsidized market.
Highly distorted, yes.
Highly distorted. Yeah. But if you were to sort of say, well, let's get that on the table, I mean, I think one of the first things we could do in the United States, just eliminate all subsidies to fossil fuel production. Let's see how that would change the playing field.
What we're dealing with, though, within individual governments is disconnects between different departments, because the departments of the environment were the ones that went to Rio and signed the UN Framework Convention on Climate Change, and the departments of trade and the departments of energy are the ones that are in cahoots with the oil business.
Right.
So governments don't speak with a single voice.
Right.
And it's up to the voters to see that they do. So ultimately it does come down to us. I mean, I could ride my bike instead of driving a car. I could drive a smaller car. All of these things. I could recycle more. All of these are small things that I should be doing anyway. But the changes we need to make are much bigger than we can contribute as individuals. And the only way we can get our governments to make those changes is by drawing their attention to the fact that there's a problem and they have to do something about it.
Well, absolutely. And that's one of the reasons I became involved in the divestment movement in the United States, because, some people say, well, how can you support divestment if you drive a car? We all use oil and gas. But this is why, because as an individual, you're living in a society that is structured, and you can make certain choices. Like you say, you might be able to ride a bicycle or take a train. I've put solar panels on my roof. I've put on all LED lights in my house. So there are certain things you can do as an individual. But I always like to say I can change my light bulbs, but I can't change my electricity grid.
Yeah.
Right? That's part of a larger infrastructure for which I need governance. And so governance, the rule of law, these things are crucial, and this problem won't be solved without that. So it's a kind of both-end thing. Individuals need to do what they can, because that can make a difference, and also because you get depressed if you don't. So, what you can do is self-empowering. I certainly felt a whole lot better when my solar system was finally working after quite a bit of work to get it working. But it's not enough. And it's very misleading, I think, to suggest that this is a problem that can be solved by individuals alone.
Yeah, well, it can be solved by individuals, but only if they decide to take action by interacting with governments.
Exactly.
And by creating movements that impress governments by their size.
And also that impress the corporate world. The divestment movement has the possibility of sending a clear message to the corporate sector. This isn't okay. It's not okay to basically compromise the future of the world for the short-term gain of selling oil and gas now. And I guess what I'd like to see people do is to bring back the BP model and say, you yourselves told us that this was possible. You had this idea. So let's talk about it again. And maybe it's not possible in exactly the way it was proposed in 1997, but let's talk about what that alternative could look like today.
And the funny thing is, although they decided to can their investment in these renewables, they represented only between 2 and 4% of their budget. So it's not as if it was a huge drain on their resources. I can imagine that BP's been squirming because, of course, with the big disaster in the Gulf of Mexico, they're having to pay out a lot to particularly U.S. taxpayers to remedy the problem that they caused.
Well, that's right.
But Shell wasn't in that position.
I know, but even that raises a good point. Somebody ought to do one of those corporate case studies and look into it. If BP had invested really seriously in renewables, instead of going the route of drilling very deep, very hard to drill areas of the Gulf of Mexico, and maybe hadn't had the BP Horizon disaster. How many billions of dollars or are we talking about there?
Multiple,
many, many billions, right? Not to mention all the losses that probably will never be actually accounted for. So, the argument they'll make is that they did what was right for their investors, but it's not 100% clear to me that that's actually even true.
No. We have a problem not only with the oil companies, so we have to recognize that there really is a problem with governments, because governments are our tool for regulating corporate activity. And for example, if you take Canada, where companies are now strip mining the Athabasca tar sands to provide, or they can only do that because the price of oil was quite high. But it's the Canadian government that regulates that activity. Similarly, in Australia, the new government in Australia has virtually ditched the carbon legislation that its predecessors put in place. You have the distinct impression that governments, it's all too easy for governments to be so influenced by the lobbying machine, which has huge amounts of corporate finance behind it. I've seen it read somewhere that the green organizations could maybe send 6 people per year to talk to a senator. The big corporations like ExxonMobil can send 60.
Right.
It's out of all proportion.
Right.
And so they get a lot more attention. And then the fact that they can put some refinery in some senator's backyard is this called pork barrel?
Well, pork barrel is when the senators themselves fund but influence peddling, maybe, I think might be the phrase.
I wouldn't want to accuse them of that.
Well, you could say there's a possibility. It certainly seems like it. Well, and, so this is where this can all become a little depressing, because then it seems like we're saying we have to change the entire political system, and that seems even more impossible than just preventing climate change. But I think it gets back to what you said about market fundamentalism and the hold that neoliberal thinking has had on us. So in the United States, the word regulation has become a kind of dirty word. And it's amazing to me how many people, including educated people I consider friends and colleagues, will say, I hate government, I hate regulation, I just want to be left alone to do.
So they don't vote.
Well, I don't know if they do or they don't, but I can't tell you how many people I know. Intelligent people have said to me, I hate regulation, I hate government.
Yeah.
But here's the thing.
But they don't. They're not joining the dots, are they?
They're not connecting the dots.
The answer to one is the other.
Right. Well, first of all, without governments, we have no rule of law. And I think anyone who says something like that ought to spend 6 months in a country that doesn't have functional rule of law, and they would very quickly rethink their attitudes about government. But also about regulation. I mean, like a lot of things, there's good regulation and bad regulation. It's certainly possible for a market to be over-regulated, and there's certainly some cases where deregulation, has helped produce products that are available to consumers at lower cost. Like the cell phone industry is an interesting example. But on the other hand, there are lots of regulations that enable us to do the things we want to do and to do them well.
Yep.
A stop sign is a regulation. A speed limit is a regulation. Not smoking in an airplane is a regulation.
Yeah. Now, market fundamentalists will tell you we don't want any regulation at all. But what they forget is Adam Smith in The Wealth of Nations.
You have to regulate the banks.
70 and 76. Yeah, that's right. You have to have regulation for certain kinds of corporation that otherwise do damaging things. And it is quite hilarious when you think about the recent banking crisis. The one industry that he pointed to was the banks.
Absolutely.
And I'm sure that if the oil business has been around at the time, he probably would have pointed to them.
I agree, and you can't. And he said very clearly, to have a functioning market system, you have to have regulations, because otherwise it can collapse into monopoly capitalism, which is what we saw in the United States in the late 19th century. And to me, one of the tragedies of the recent global financial crisis is that many of the regulations that were put in place during the Great Depression in response to the abuses of the Gilded Age were gradually dismantled.
Yeah.
And guess what? Second Gilded Age, second stock market crash, many things that were not only predictable, but in fact were predicted by people who were paying attention.
Part of our problem as human beings, though, is that collectively we find it difficult to act in the face of slow changes until they become almost intolerable. I'm reminded, being as I am from the UK, in the mid-1800s, so much sewage was dumped in the River Thames that London was so smelly. They called it the Great Stink.
Right, and Parliament complained, right?
Eventually Parliament was going to move upriver to Hampton Court, and the law courts were going to move to Oxford. Until finally they employed this civil engineer to put these huge tunnels in that take the sewage away and take it further downstream where it wasn't causing so much of a problem. So it does take people a long time to act. The smog is another problem. You've had that in Los Angeles, you've had that in London, other big cities. It was not until something like the late 1950s and early 1960s that climate regulation or air quality regulation finally came in to stop these things happening. So we can change the environment.
Exactly.
But it's just that we don't tend to do it until a catastrophe. I have to tell you, when I worked for UNESCO in Paris, we had a proposal on the table to spend $30 million for a tsunami warning system in the Indian Ocean. Guess who didn't buy it? The governments of the Indian Ocean. Wow. Then along comes the big tsunami in Phuket.
And everyone says, why didn't we have a warning?
What do we have now? We have a tsunami warning service. It's just so sad that it had to wait till 250,000 people died before they actually got it. But can I just say one thing about the smog, though, too, because I think we have like a couple more minutes here. I think the smog is a really good example for us to take to heart, because people did have to die, and it was after the deaths in the big London smog, that in fact regulations began to be passed. And that tells us two important things. One is that I think that if we have evidence that people are dying from climate change, we need to be not afraid to say that. A lot of scientists I know think it's too inflammatory to say, well, some of the deaths, say, in the recent typhoon in the Philippines were probably caused by the greater intensity of that typhoon because of climate change, that's something that they shouldn't say, that it's not appropriate to say things like that. But I actually think it's essential. I think people need to understand that people are dying from climate change already now, because it's the deaths that really get people to take it seriously. It's sad, but it's true. But then the good news of the smog story is that we fixed it. And you can go to Los Angeles today, and Los Angeles is a beautiful city,
And you go there today and you think, wow, you know, with the right science, because a big part of the smog cleanup involved figuring out this photochemistry of smog, the right regulation, the right will, and getting industry to play ball, to be on board, to say that it's actually in the interest of industry to keep Los Angeles a livable city, right? So in a way, there's a happy ending in that smog story, and that makes me optimistic. You know, we could have happy endings in other areas too.
Well, what I'd like to do before we finish is go back to what you said about divestment, because in the UK, for example, Glasgow University has now divested itself of all of its investments in anything to do with fossil fuels, and I think they are trying to set an example for other parts of the UK academic system certainly to follow. I think the church has a big role to play globally in divesting itself of these kinds of investments, and that would send a powerful message to churchgoers, for instance. So those are two things that one can do immediately. Now, there's another thing that recently happened in the UK. I don't know whether it's happening in the United States, but students of economics at Manchester University are in a state of revolt about the teaching of economics, because they feel it's all this classical Chicago-style crap is, you know, just not working, and they shouldn't be teaching it.
Hallelujah.
So what
it's about time.
What they want to be taught is they want to be taught by Thomas Piketty from France, by Jacob Stiglitz.
Joseph Stiglitz.
Joseph Stiglitz and by Paul Krugman.
Yeah, interesting.
These are people who have a solution to how we should approach the economics.
Right, or at least they have a conversation that they've started, right? Because there's been a kind of conspiracy of silence among academic economists, in my opinion, not to talk about these market failures, not to talk about the reality of what's actually happened in our economic system and the tremendous growth of inequality. It's all supposed to be good, you know. The rising tide of deregulation was supposed to lift all boats, and that hasn't happened. So we should be having a conversation about that, and so that's amazing and great that the students are demanding that conversation.
Yeah, well, I think a lot of this has got to come from the bottom up.
Yeah, well, and it is, clearly is already.
More power to them.
Yeah, definitely. Is that our signal? Are we done? Great talking with you.